Thank you. Thank you. I just realized I'm wired here. I have no pockets. Well, the Rochester Institute of Technology estimates that federal regulations this year will cost Americans over $600 billion. That's about $6,000 per household. Now, the annual burden of regulations is about to ratchet up again by about $1,000 per household. This expensive increase will result from attempting to remove chlorine-containing refrigerants such as Freon from society. Freon 11 and 12 and other chlorofluorocarbons, CFCs, will not be manufactured in the U.S. after December 31st of this year. And Freon 11 and 12 are the major coolants and refrigerants used in this country. Related compounds like halon are already banned from manufacture, and you may know that halon is used in fire suppression. Now, the reason given for the manufacture ban and the de facto ban in use, well, CFCs erode the Earth's ozone layer, and this erosion will cause major harm to human health. But science tells us these fears have been greatly exaggerated. And what is sinful about doing away with Freon is that it will not have much of an impact on the ozone, but it will certainly have a great impact on our economy. Over $100 billion worth of equipment will need to be replaced or modified because the replacement chemicals for CFCs cannot easily drop in to existing equipment that now cools our homes, cools our autos, and keeps our food and medicines safely chilled. As a result of this painful economic choice, we'll have to either stick with controlled substances for our current equipment, Freon 11 and 12, for example, or replace our old equipment, which may still be functioning, with new equipment that accepts the replacement chemicals, or just do without air conditioning or refrigeration. And according to U.S. House Resolution 291, put out in 1993, the accumulated cost of these painful economic choices will be about $2 trillion ripping through the U.S. economy. Now, what are the scientific facts underlying this punishment of the U.S. economy and the lives of its citizens? Ozone is made in the stratosphere when ultraviolet radiation from the sun breaks apart an oxygen molecule, O2, two oxygen atoms, into the oxygen atoms. An oxygen atom then can combine with O2 to form O3, ozone. Now, manufactured chemicals such as Freon containing chlorine and bromine containing compounds such as halon are theorized to interfere in this process and cause a net destruction of ozone in the upper atmosphere. Over time, that erosion of ozone, the theory says, should allow more ultraviolet rays from the sun, and specifically ozone blocks light at wavelengths from 280 to 320 nanometers, called the ultraviolet B spectrum region. Those rays should increase at the ground level, and in turn, that enhancement in ultraviolet B radiation on the ground is expected to cause biological damage, including cancer, skin cancer specifically. Now, how do CFCs lead to the destruction of ozone? The CFCs, which are generally chemically inert in the atmosphere, diffuse upward, and yes, indeed, direct measurements in the stratosphere show that they do make it to the stratosphere. And some kinds of CFC molecules break up by being hit by ultraviolet light from the sun and release their chlorine atom. Now, according to the theory of ozone depletion, the chlorine atom interferes with this process of making ozone by grabbing one of the free oxygen atoms in the stratosphere. So the oxygen, instead of combining with an O2 molecule to form O3, reacts with the chlorine to form chlorine monoxide. And chlorine stays in the stratosphere for decades, so it can cause this net destruction of ozone for many years. And the theory says that a significant buildup of man-made chlorine in the stratosphere and bromine as well, ought to lead to an inexorable decline in ozone. Now, in 1991, the administrator of the Environmental Protection Agency, William Riley, said that ozone decreases were, quote, more serious than we thought, and that deaths due to skin cancer would double in the next 40 years. The EPA estimated in 1987 that the future ban on the production of CFCs, as introduced by the Montreal Protocol, would save the U.S. some $6.4 trillion by the year 2075 in reduced costs associated with skin cancer, mostly by preventing death from melanoma. So that's $6.4 trillion accumulated in net savings by reducing the costs associated with skin cancer, combined with the mere $2 trillion associated with switching over from CFCs, meant a net good. But the scientific facts clearly indicate, first, there is no observational evidence that man-made chemicals like CFCs are dangerously thinning the ozone layer over most of the world. And second, the kind of ultraviolet that would be let through by a thinner ozone layer, UVB, is not now implicated in melanoma. On two counts, the hysteria and the costly regulations around them are entirely unfounded. Well, first, what is really happening to the ozone layer? And if we could have the slides turned on, first slide. We might have to dim, I think, the fluorescence. Can we get rid of them altogether?
You just turn the lights out in the room.
I don't see any light switches from here. Is that visible in the back? It's not very, is it? It's all right? Well, I'll try to explain it. The kind of measurements from which ozone decreases are inferred are shown in this slide. This is the ozone measurement made globally by a satellite called the Total Ozone Mapping Spectrometer, an instrument on various satellites, beginning in late 1978 and 1979. So the first thing to note is the record is very, very short. And I have not shown the data beyond 1991 because of the influence of Mount Pinatubo's eruption on the ozone abundance. And we'll discuss volcanoes in a few minutes. So this record goes from 1979 to 1991. It is the global average of ozone averaged over the northern and southern hemispheres, much better, from 69 degrees north to 69 degrees south latitude. That is, I've excluded the polar regions for reasons we'll talk about in a minute. And this is the area where most of the population lives. Now, there's several things to note in this chart. First is there is a very large, in fact, the largest change is season to season, spring to fall, opposite in both hemispheres. So you're getting a sort of a double variation every year. And that is superposed on that are some other effects we'll talk about in a minute. But between 1979 and 1985, when the Montreal negotiations were getting underway, there was a linear decrease from here to here. That trend extrapolated is about a 3% decrease in ozone per decade. Now, note that this 3% per decade decline that is often cited by the EPA depends on the interval that one chooses for analysis. For example, between 1985 and 1991, when Mount Pinatubo erupted, there was an increase in ozone. Now, clearly, since chlorine had been building up in the atmosphere, and chlorine could only lead to a decrease in ozone, that increase after 1985 must be the result of natural factors. So this slide shows that natural variations cause much of the ozone fluctuations, the seasonal, and in fact, this is caused by the 11-year cycle of solar variation. And these two effects are much greater than that of the man-made chemicals. Now, it's also relevant to note that the ozone layer, although this is an average over most of the globe, the ozone layer thins towards the equator. If one moves from San Francisco to Los Angeles, for example, the permanent average decrease that one suffers in ozone abundance is 25%, nearly 10 times the accumulated decline over a decade, which alarmed EPA Administrator Riley. Now, second, the 3 million cancer deaths by the year 2075 mentioned by the EPA refer mostly to malignant melanomas. It is a rapidly metastasizing skin cancer that has been increasing since the 1930s, long before the widespread use of CFCs. Epidemiological studies, however, say that melanoma is not explained well by long-term exposure to UVB. And in fact, laboratory studies of possum, rats, and fish suggest that melanoma risk is enhanced by longer wavelengths of light, not UVB, but perhaps UVA or even ordinary blue sunlight. In fact, the latest United Nations Environmental Protection Report on ozone and its environmental effects very timidly concurs, quote, "There is uncertainty about the relative importance of UVB radiation in determining an increase in melanoma." So for non-melanoma skin cancers, there is a link to UVB, but for melanoma skin cancers, there is yet one to be found if it exists. Well, this means that changes in ozone, which only block UVB, ozone is only blocking UVB, not any other wavelength of light, can have little impact on the incidence of melanoma. Oh, even apart from the question of whether ozone is decreasing and UVB flux is increasing at ground level, the EPA warning in 1991 on deaths due to melanoma is entirely without foundation. Now let's go back and look a little bit closer at the ozone loss due to man-made chemicals. The overall measured decline, this natural plus man-made, is less than this 3% per decade, which we've seen as exaggerated. But what part of that is due to man-made chemicals, and what part might be caused by natural variations? In order to do that, one must correct this record for all the natural influences known that are known. And that correction process is subject to large systematic errors, since these natural effects really are much larger than the man-made effects and in fact may not be entirely known. And they can vary in unpredictable ways. For example, when the seasons are subtracted from this data, a sinusoid is used, just a simple sine wave with a period of twice, two period per year. And of course that it doesn't involve physics, it's just mathematical manipulation, that the seasonal change is always the same. Now, in addition, as we noted, the results for this trend analysis strongly depend on the endpoints one chooses in the analysis. And because this record is so short, one has to worry about whether the starting point of this record has an exaggerated high point or local high point of a longer record. So as a result, the data are consistent with zero man-made trend because the subtraction process for the natural processes is so fraught with uncertainty. And in fact, again, the UN World Meteorological Organization report concluded in 1991 that there is not a full accounting of the observed downward trend in global ozone. Now, longer records of ozone abundance made from the ground exist in some areas of the world, and they are extremely valuable for telling us the amount of natural variability of ozone, especially where measurements were made before substantial buildup of chlorine in the stratosphere. And two records I'll go over are very useful in helping define the natural fluctuations of ozone. Next slide is records of total ozone that have been measured and combined very carefully from 23 ground stations in the northern hemisphere, covering latitudes 30 degrees north to 60 degrees north, again excluding the poles. Now these records begin for several of the stations in 1957, so it's 2 decades before the start of the satellite data that I just showed you. And the earlier portion of the record certainly includes ozone fluctuations that are undisturbed by the recent buildup of CFCs and chlorine in the stratosphere. Now, there are several important aspects in this slide. Now, first, the record is the monthly total ozone deviation in percent relative to the average over the whole record. So the record goes from plus 3% down to minus 3% from a base level of about 300 of these Dobson units, which is the amount of ozone in a 1 centimeter squared column above the ground. So in this 35-year record, there's a change over the northern hemisphere of plus 3% to minus 3%. And I've also, this record, I've ended it before the eruption of Mount Pinatubo, again, not to get the influence of the volcano at the end of the record. Now, the second thing to note is that the seasonal fluctuations have been subtracted out of this record. Those twice per year, northern and southern hemisphere, spring to fall fluctuations. Now, third, recall that the satellite records started in 1978 to 1979. Now, if we look back at this longer record, we see 1978 to 79 is at a time of a relative high point. So it's a little unfair to exaggerate your downward trend by choosing a starting point that is unusually high. And in fact, longer estimates often are made to the to 1970, which is the highest point of all in this record. Those guarantee that your trends, your man-made trends, will be exaggerated. So decreases computed from these high starting points for the natural, for the man-made effect are exaggerations. Now, another point to note is that the entire 6% amplitude from plus 3 to minus 3%, the change in ozone that one sees, occurs in this record in a very short interval, namely from the start of the record, 1957, to the early 1960s. Now, this huge change certainly occurred before the buildup of the man-made CFCs and chlorine in the atmosphere, and so this change must be entirely natural. So again, we are talking about a man-made trend that is much smaller than the natural fluctuations that have been measured. Now, finally, there is a trick here. Note the trick that's used. We're talking about changes of a fraction of a percent per year, several percent over a decade. The 0 point on this chart has not been shown. So let me restore for you in the next slide the 0 point. You have to remember the 0 is about 300 Dobson units. And if you flip to the next slide, it's the exact same data showing you what the concern is about the total amount of ozone over our heads. On this scale, the fluctuations in ozone and its recent diminution that we've all been so concerned about are shown in their proper perspective. That is, they are unnoticeable. Now, a much longer record comes from Tromsø, Norway. It covers a very limited region of the Earth, but it spans 50 years, from 1935 to 1989. These measurements are much less precise than the satellite measurements, but they do indicate in a long record a substantial amount of natural variations because they go back so far in time. And the next slide shows these records from Norway. And again, this scale now goes from minus 8% to plus 10%. And you can see the natural variations here are enormous. For example, ozone dropped 15% over just 3 years in the early 1940s. And in the early 1960s, ozone over Norway was roughly 10% lower than it is today. Now, all these fluctuations occurred prior to the widespread use of CFCs and therefore must be natural. Now, ultraviolet B radiation, whatever the downward trend in ozone, the increase in ultraviolet radiation that is supposed to accompany this downward trend in ozone has not been seen. Ultraviolet B measured in the US at 8 stations either decreased or did not change at all at ground level in the continental US between 1974 and 1985. Now, interestingly, after 1985, the measurements were dropped because funding for the program was terminated. Now, one sustained effort of ultraviolet B radiation monitoring, which began in 1975 and continues at a Smithsonian laboratory in Maryland, also does not show an expected increase in ultraviolet B as the ozone has been declining. Now, at that latitude, the ultraviolet B dosage declined 20%, despite the fact that ozone declined 4% over the interval of overlapping ultraviolet and satellite ozone measurements, namely 1979 to 1990. Now, this doesn't surprise me. Clouds and other factors can affect the amount of ground-level ultraviolet B radiation, so the observed decline is not, the fact that there is no observed decline is not troubling. There is another ultraviolet B record that comes from Toronto, which was widely hailed in the media as proof that CFCs cause ozone depletion. Now, that claim is wrong on two counts. First, the Toronto record, although the measurements are very good, the record is very short. It's only 4 years long, and it's much too short to establish any long-term trend. Nonetheless, the authors claimed an astonishing 35% per year increase in ultraviolet B radiation. And subsequent analysis of this record proved the trend to be an artifact of the author's analysis. That is, the interval of the analysis ended with 4 anomalously high days of UVB radiation. And those anomalously high days of UVB radiation were caused by a storm that had temporarily swept ozone away, as storms often do. So omitting those 4 anomalously high last days at the end of the record resulted in a boring but accurate conclusion that ultraviolet B had not increased over the interval. Now, the second reason why the media was wrong in thinking that this paper proved CFCs caused ozone depletion is that the paper had nothing whatever to say about the cause of the measured variations. It was merely about observations of ultraviolet flux. So there is no evidence for an increase in ultraviolet B dosage as ozone has declined by this few percent. The executive summary of the 1994 United Nations Environmental Panel sheepishly confirms this by saying, uncertainties in calibration, influence of tropospheric pollutants, difficulties in interpreting data from instruments continue to preclude the unequivocal identification of long-term trends. In other words, there is no long-term diminution. So the evidence tells us that ozone changes in the inhabited portions of the world are primarily the result of large natural fluctuations, such as changing ultraviolet output from the sun, meteorological conditions, such as the quasi-biennial oscillation, shift in winds, upper stratosphere winds, and El Nino events, warming pulses in the tropical oceans. As yet, no evidence suggests a man-made ozone crisis or a crisis in increasing UVB radiation over most of the world. However, the lack of a program of systematic measurements of UVB is unconscionable, considering the dire health threats that are supposed to be accompanying the declining ozone and concomitant UVB increase. Now, what would a delay of, say, 10 years do in the cutoff of manufacturing CFCs? What will that cost us in added UVB exposure? Well, let's assume that the man-made loss is as large as 1.5% per decade, about half the trend the EPA considers. And let's also assume that the UVB increases are as large as predicted, even though the measurements say otherwise. That would mean an additional UVB dose for about 10 years beyond what it would otherwise be after 50 years, the time now estimated to restore the ozone layer. That extra 1.5% decrease in ozone is equivalent to moving 20 miles closer to the equator for 10 years. Now let's talk about the Antarctic ozone hole. The ozone record is quite different in Antarctica than in the rest of the world. There, the ozone has been dropping to very low levels at some altitudes nearly every spring, which is October in Antarctica. And the amount of thinning seems to have leveled off in recent years. This annual thinning is triggered by the extreme cold and special meteorology in the Antarctic upper atmosphere. Now, the term ozone hole is hyperbole. The total ozone never disappears completely, and the ozone recovers after about a month or so. The dramatic ozone decline is a temporary annual event. The natural variability of ozone in October over Antarctica is an open question. That is, did these dramatic changes occur before widespread use of CFCs? We do not know. Accurate measurements over an interval that long are lacking, and there certainly is no theory that exists to explain why the annual ozone thinning occurs in the first place. The 1994 United Nations Scientific Assessment concludes, quote, "There is no evidence of major springtime ozone depletion in Antarctica at any of the 4 Dobson stations prior to 1990. But absence of evidence is not evidence of absence." Now, according to the theories of ozone depletion in Antarctica, the stratospheric temperatures must drop and stay below minus 80 degrees centigrade for a significant time in order for this depletion to occur. The next slide shows average October ozone levels over Antarctica, along with the deviation in the stratospheric temperature between 1978 and 1993. These are all the satellite data that we have, and it includes the interval, the 3 years after Mount Pinatubo's eruption, which are these triangles here, where you see the ozone was particularly low. But ignore those for the moment, and according to this chart, it's not the amount of chlorine that is controlling the October Antarctic thinning. Chlorine stays has stayed at its very high levels or has increased a bit throughout this period. It is the stratospheric temperature. When the October stratosphere is cool, the ozone abundance drops. And conversely, when the stratospheric temperature in October is warm, the ozone abundance is quite high. In fact, in 1988, although this did not make lurid headlines, there was a very warm Antarctic stratosphere and no hole ever developed. Now, in fact, this is a depressingly short period of data, but there are long-term temperature trends that may be responsible for the current low levels of ozone over Antarctica in October. For example, there is a pattern of correlation between sea surface temperature in the tropical Pacific in the summer and then the following temperature in October over Antarctica. And we do have sea surface temperatures going back much further than these records of the tropical Pacific. If that correlation holds, it suggests that in 1975, conditions turned correct, that is, the stratosphere over Antarctica cooled somewhat and set up the conditions for these major ozone losses in October. And prior to that, the stratosphere had been much warmer. So it says that there are long-term temperature effects that may also be fooling us when we look at these records. Now, some additional facts about Antarctic ozone is that recent observations that have been made from the Space Shuttle Atlantis show that, unlike we read in the newspapers, the hole cannot gobble up the rest of the world's ozone. The hole is confined strictly to the frigid isolation of the Antarctic stratosphere in a region called the polar vortex, high-speed winds that whirl above the continent of Antarctica and isolate that region from the rest of the world. So the hole cannot expand beyond the polar vortex. And also note that the extraordinary sustained cold of the polar vortex does not occur anywhere else in the world, and that is, the ozone hole cannot occur anywhere else, even the Arctic, which doesn't have the sustained cold. Now, this fact was ignored in 1992 when NASA announced that there was an ozone hole about to open up over North America. And that was based on this specious reasoning. But based on that specious reasoning, the phase-out of CFCs were accelerated to their current schedule. Freon was scheduled to be phased out and manufactured the year 2000. It was moved up 5 years by a 99-0 vote in the Senate. And based on in fact, incorrect scientific evidence. Now, as for the local biological effects of increased ultraviolet B in Antarctica due to these measured low intervals over the past decade, well, the sun is barely above the horizon in October, having just risen at the end of September, and so the greatly slanted rays of sunlight are quite weak. They're scarcely 1/50th of the radiation, the ultraviolet radiation at the equator. So claims of calamitous ultraviolet B disasters are fiction, blind sheep and whatnot. And serious studies of, for example, the phytoplankton in Antarctica show that the species have neither declined nor died out over the last 20 years during which they've been exposed to this ozone hole. They have flourished just as they always have. Now, there are a few other factoids and myths concerning this I'd like to mention, and three of them are particularly irritating to me. One is that the statement that CFCs are, quote, relatively insoluble in water, meaning that the ocean will not absorb any of them. Oceanographers must be offended by this statement because CFCs, including Freon 11 and Freon 12, are used as tracers of the ocean currents and circulations because they are dissolved in ocean water down to very deep levels. In fact, a recent paper reports in the journal Oceanography that dissolved Freon 11 and Freon 12 concentrations in the near surface layer of the North Atlantic were within a few percent of the atmospheric equilibrium values at most stations. Now, the second irritating myth, and my final slide, if we could put it up, is that volcanoes have nothing to do with ozone levels. Volcanoes have several relevant features. The 1991 eruption of Mount Pinatubo clearly caused a several percent temporary decline in ozone, and that's why I had marked those special points in the Antarctic chart that I showed you. Now, the Mount Pinatubo caused destruction of ozone over the 3 years that it was most effective, was more than the total accumulated man-made depletion to date. Now, the cause of the depletion is an area of active research and hot debate. Some believe that aerosols from the volcanoes cause the depletion, not the release of chlorine from volcanic gases. And that brings me to a related irritant in this topic of volcanoes. It is without doubt that volcanoes loft hydrogen chloride high into the stratosphere because there occur temporary spikes in the records of hydrogen chloride emissions after volcanic eruptions. And it's in these and volcanoes also emit directly to the stratosphere when the eruptive events are that explosive, large quantities of hydrogen fluoride. Now, you need to understand that hydrogen fluoride, the presence of hydrogen fluoride in the stratosphere is assumed to be the fingerprint of the breakdown of the CFCs and is used as a proxy for the presence of chlorine because hydrogen fluoride is assumed to come solely from CFCs. Well, statements like that must surely offend volcanologists because hydrogen fluoride and hydrogen chloride are two of the top 3 gases most commonly emitted from volcanoes, especially in explosive events where the gas goes right into the stratosphere. And you might remember a NASA press release in November 1994 that offended most everybody. In that press release, NASA scientists claimed to have, quote, proved that stratospheric chlorine comes almost solely from CFCs because they assumed that hydrogen fluoride, the marker they were using for chlorine, has no natural sources. Now, an interesting paper recently came across is volcanoes also appear to emit naturally made CFCs, including Freon 11 and Freon 12, in quantities far above background levels and in cases where contamination is not suspected. And I must admit, though, that volcanoes, although they may make CFCs, they probably only manufacture a fraction of the man-made release of CFCs. But it points out that our knowledge of naturally occurring organohalogen compounds, including, by the way, dioxin, made by natural enzymatic, thermal, and other properties, is relatively new. Certainly these chemicals are not the evil handmaidens of industrial man. They have been in the ecosystem for a long time, having been created naturally. Now, the third irritating myth that I want to briefly mention is that there are no sinks of CFCs other than destruction by UV radiation high up in the atmosphere, where they then allegedly cause their mischief to the ozone layer. The fact that there are natural sources of CFCs would suggest that there are also natural sinks. Indeed, there are several. One sink is biomass. Biomass burning releases high emissions of Freon-12, for example, which means that Freon-12 had previously been deposited on the biomass. Fire merely resuspends the Freon-12 back into the air. Another sink is the vigorous consumption of Freon-11 and Freon-12 by anaerobic sediments in and soils. In other words, microbes may be eating the chlorine from the CFC molecule. Now, how much soil worldwide could harbor this sink of CFCs is really unknown. Now, I want to make some comments on policy as it has not followed the science. So given the insignificant amount of actual recent ozone loss and the facts casting doubt on catastrophic thinning of ozone, it is instructive to look at the rationalizations, and I say rationalizations because it's not logic, for the CFC regulations. It is claimed that the policy should err on the side of safety. Such a policy basis is called the precautionary principle, which, roughly translated, is a dictum to do no harm in the absence of knowledge about certain safety. And that adjective certain in front of safety is quite important. Now, if the economic burdens associated with these environmental actions were trivial, then policy decisions made in accord with the precautionary principle would be easy. But the cost of the CFC decisions is rather great, and such policy decisions, once made, are difficult to reverse in some sort of law of policy. Now, the precautionary principle introduces a notion that actually destroys the scientific basis of the policy debate. The precautionary principle forbids human action unless it is certain that this action will cause no harm. This is antithetical to science, in which progress means less and less uncertainty, but full certainty is never achieved. So the precautionary principle, which is used as the basis for formulating these policies, is the denial of science. And the inseparable obverse of the precautionary principle is that given any theoretical possibility of harm, no matter how great the uncertainty in the theory, we must take action to prevent the possibility of that harm. As a result, full and open discussion of uncertainty of a theory is censored, inevitably, because such debate is irrelevant. Even if a policy of wait and see is based on the best available scientific facts and the best economics, it is not an appropriate environmental decision. Policy made in accordance with the precautionary principle is conveniently and horrifyingly divorced from both science and economic consequences of the environmental impact. That leaves, unfortunately, unchecked the policy urge to, quote, always do something. And this, in fact, leads to a disturbing pattern that has been emerging from the CFC and the CFC replacement policies. The replacement refrigerants are now on the table as being banned. Some of the HCFCs replacing the CFCs, for example, still contain chlorine. So they too must be banned, say, in 20 years, although our experience shows that those phase-out dates are always pushed up because things are always worse than the theory expects. And the replacement chemicals HFCs, which contain no chlorine, are thought to be now strong agents of global warming. So they too are being banned, especially in Europe. And you may have read a recent paper in Nature where one of the primary replacement car air conditioning replacements, R134A, is now thought. Now, these replacement chemicals were designed not to be chemically inert in the atmosphere, but to specifically react in the atmosphere and therefore not get a chance to get up to the stratosphere. These replacement chemicals, like R134A, are now suspected in computer models of all things of being sources of terrific acid rain that will endanger the temporary wetlands that form in the Northeast. So there is no observed change in global ozone concentrations that is outside the bounds of known natural variability over most of the world. There is no scientific merit to the claim of an ultraviolet catastrophe by precipitous ozone loss. Building on a case without scientific justification, policymakers have put in place restrictions on CFCs that will be extremely costly in dollars and in lives. Over 600 heat-related deaths occurred in Chicago during the July heat wave. Shouldn't policymakers consider making air conditioning less expensive rather than more expensive? Here is an example of a real catastrophe. It lies in the squandering of resources that could be better used on real problems. Thank you. We have time for a few questions. Yes?
On a warm summer day, I believe a typical backyard swimming pool will have about a half a gallon of chlorine evaporate from it, and every household must go through a cup or two of Clorox a week. How does that compare with the leakage or the dissipation from the replacement of the Freon in refrigerant machines?
I'll try to repeat the question into the microphone. The question is, what about chlorine from swimming pools, salt spray from oceans? Does that not dwarf any man-made emissions of chlorine from CFCs? And I have two comments to make on that. One is that, yes, the ocean evaporates a tremendous amount of salt spray into the atmosphere. The counter-argument is that that often doesn't make it up to the stratosphere because it's easily dissolved and rinsed out in rain. However, it doesn't rain everywhere over the earth every day, all the time. All day. And so I think the answer to the question is it's unknown how that competes. Certainly thunderstorms that detrain high up into the stratosphere are carrying salt spray from the ocean directly into the stratosphere. Again, an unknown amount. But my second question refers to this precautionary principle in policy. There is talk about banning all chlorine from the earth because, after all, it sooner or later may make it up there to the ozone layer. So again, it's this nonsense that has put us on this path. There's a question up here. Next, go ahead.
Is the material you presented today available in written form, for example, in the Marshall Institute study from 1994?
The Marshall Institute kindly FedExed me a box of pamphlets where I did a study last summer that's being updated this summer, and you can have, I don't have copies for everyone, but anyone who wants them can have it. I also have a pamphlet. Please call them if you don't get one today, and they'll be glad to mail one out for you. So I'm about to put them out on the table. Yes, go ahead.
Do you publish these things on the internet, on the website?
No, I don't. My life is so complex, I can't. I put them out in booklets at the Marshall Institute. It's just too much for me to add on internet, although we should get a website that says at least these publications are available. Green, yes?
The United States Congress has a monthly corrections day for ridiculous legislation. Would you be willing to assist refrigeration engineers, dermatological society leaders, and others in preparing for a corrections day?
I certainly would be delighted. The question was, I think everybody heard that there is a corrections day for silly legislation. And in fact, there are several congressmen, DeLay and Doolittle, have been putting in legislation for the past several terms to try to strip the EPA of its authority to regulate anything it thinks causes harm to the stratosphere, which is an overly broad legislation. Another one is a bill that is just now being filed is to move the ban of manufacture of CFCs back to the year 2000 deadline, which was fraudulently moved up by this bad press release in 1992. That one is about to be put in. I should mention that Arizona went and did the right thing, which is that they have just passed a bill, signed into law, taken effect, saying notwithstanding any international treaty or federal law, they will allow the manufacture in an unregulated way of CFCs, and they're expecting a court case. They have no manufacturing facilities in Arizona, but they would like somebody to manufacture a few molecules so that they can make a test case that this is in their economic interest, not a province. It's a states' rights issue, not the province of the federal government. Yes?
Has the media, the mainstream media, taken an interest in you and what you have to say, and what's been your interaction with the media and with environmentalists?
I present the scientific, the question is how do the media respond to this, and my interaction with other environmentalists. I'm also on, quote, the wrong side of the issue in global warming because the scientific facts say there's no catastrophe there. And I spend a lot of effort explaining this very carefully to policymakers and media people, presenting the scientific facts. The media have been very honest in telling me that because there's no catastrophe, it's really not news. Is a question in back? Go ahead. Go ahead. Anyone? Yeah.
Our table wants to get rid of a vicious chemical reactant called oxygen.
It rusts.
Do you or anyone else know if there's any truth to the rumor floating around that Freon is now losing its patent, and therefore something's happened in this respect?
I have read this in several places, and I haven't been able to do my own research to confirm it. The question is, did the patent run out in Freon, and so the underlying issue is, does industry have a vested interest in a controlled chemical? I've read it several places. I can't confirm it, and I don't know enough to do so. But it's certainly, industry has made a decision that they don't want to return from. They've had to invest about $500 million in manufacturing equipment to go to the new chemicals. I would say that for the bottom line consideration, they are pleased that their chemical is approved in this widespread use. I don't attribute that to evil. Just that's the name of the game in industry. So I can't answer the question about whether the patent ran out and whether the industrial concerns took a more active interest in seeing this changeover happen. I don't know. Go ahead.
Can you give us the phone number for the Marshall Institute in case we don't get one?
Yes, the phone number, please call 202-296-9655.
Repeat.
202-296-9655. Yes.
Yeah, in the 1970s, there was a spate of books out about the coming ice age. And in the 1980s, the greenhouse effect became popular. And now we have the ozone menace. What is the next global environmental?
Well, actually, global warming will make the regulatory costs of CFCs and the societal costs seem like small change. In 1970, it actually happened that ozone came first and is openly looked at as a dress rehearsal for putting in more onerous regulations concerning global warming, because there the issue is the buildup of carbon dioxide, which is hard to control. It's not like CFCs and air conditioners. Carbon dioxide is ubiquitous. The issue, what happened in the 1970s, the temperature was dropping, especially the temperature in the Arctic, And that led some climatologists to say, gee whiz, this looks like what happens at the onset of an ice age. And then popular books got written about this, and some climatologists even found out that they made money promoting this. 1980, the temperature reversed. The same people who wrote some of these popular books, Stephen Schneider comes to mind, now says that no, we're not going to freeze in a major glaciation. We are all going to die in heat. And he's still making money off of it. So he's been rewarded for this. The issue there is really quite clear. There is no evidence, again, linking large warming to man-made pollutants, and it's another hour lecture. And actually the ozone booklet I brought has a second section in it with a bit of this global warming. So pick up the booklet. Yes.
We'd like to thank you for testifying in Arizona.
Oh, thank you.
About what's going on. Excellent job. There is some information on the table from the Society for Environmental Truth about the legislation that's been introduced into Congress.
What Jane was saying is pick this up and gives you exact information for contacting your congressperson to support the specific legislation that would postpone the ozone ban to the year 2000.
Yeah, this is the political way this is going to be handled is to try to get the manufacturing ban moved back to the original date of the year 2000, and then given 5 more years of fighting, perhaps then remove the manufacture ban altogether. So it looks to be a 2-step process. Yes?
Have you ever met Michael Oppenheimer? Or
I worked with Michael Oppenheimer when he was at Harvard.
does he avoid you nowadays?
He won't debate me. Yes?
Is most of your information available in your book from the Marshall Institute?
Yes. Yes. Except if you, in a few months, call the Marshall Institute back or call them and say you want to be put on the mailing list for my updated book, which has a few more this year's information in it. The book came out last December. Yes?
In lieu of monetary gains maybe from your book sales, why in your estimation do you think these people would report such misinformation when it will affect our economy so adversely? Is there some hidden agenda? Is there some gain?
I can't speak for why these people do the things they do. It's not science, and so there must be some other reason. And I just don't know their thought processes. To me, the scientific facts are quite clear and quite relevant. Whether or not there are other items on their agenda, like controlling world population or getting rid of punishing industry, punishing the U.S. economy, I just can't speak for them. Yes?
To settle the patent situation, if you'll remember, Freon is a patented coin name for DuPont.
Right.
The patents rolled out, if you remember, years back, when the patents rolled out, they were complaining, others were complaining that they didn't want to use Freon. So it changed from Freon 12 to R12, if you remember.
Right.
And R22, meaning that this was general. So there's not been any patents on this for some time.
Mm-hmm. Okay, thank you for supplying that information. Yes?
Is there a way to use glacial records to get an even longer-term idea of ozone change?
There's no marker in the glacial records. The question is an interesting one that I've often struggled with. You can drill deep cores several kilometers deep into the never-melting ice up in Greenland and down in Antarctica and pull up layers of history that's precipitated out every year. And it gives you a nice 200,000-year measurement of the amount of carbon dioxide and the temperature of the atmosphere going back that far. And the question is, is there something about ozone that would help us learn the natural variability? There's no marker in those ice cores that anybody's thought of that would tell us what the ozone was doing. Yes?
Have you calculated or looked at the real risk of workers who have to handle the corrosive chemicals involved in the replacements for freon?
I have heard this and got some of the fact sheets for the replacement chemicals. And there really hasn't been enough of a study over enough time to know what the impacts are, if there are any. I have seen press releases come from opposing companies. That is, a company that adopts one replacement will issue a press release saying the other guy's replacement chemical is toxic and hazardous. But I think the issue is unknown. I know they tell workers to wear masks and protective gloves, and they complain of dermatitis when they handle some of these chemicals. So I'm not sure we know what the answer is.
So we're replacing an imaginary threat with a very real one.
With one that is showing up, and in fact we're scheduling to phase these out as well because we're on this precautionary principle road. Yes?
Are there any studies or area of inquiries on the cost of delayed access and higher cost of access to refrigeration in the underdeveloped nations?
Well, the underdeveloped nations, in fact, are going to be allowed to manufacture Freon for another 10 years. And there's been, it is now coming over the borders of this country, the second most popularly smuggled chemical, apart from cocaine, is now Freon. It's freely manufactured in India, and I believe Mexico has access to it or is opening a plant, and it sneaks into the ports of the U.S. just as cocaine does. And there have been several arrests. There's a $10,000 bounty if you report someone to the EPA who is inappropriately using or smuggling or lets Freon leak out. There are several people rotting in jail at the moment because of this. And I think several big fines and multi-million-dollar fines against these criminals.
How many of the heat wave deaths were due to the fact that people could not afford to fix their air conditioning or to buy it?
I haven't seen any study of that, so I don't know. I just noted that there were 600 heat-related deaths. I assume if they had air conditioning, they would have turned it on, and that and that it would prevented most of them. But I don't know the fraction. I wish I did. Yes.
Seeing you're so enthusiastic about politicians, let me ask whether you think it's apocryphal that the two politicians whom you mentioned favorably, their names are Delay and Doolittle.
I can't top that. Thank you so much. Yes.
By scientists from NASA. And there was an interesting exchange. One person in the audience said, quote, what's the current information about all this ozone depletion? And the scientist said, well, we're no longer worried about ozone depletion. It seems that any loss of ozone is precisely offset by increasing carbon dioxide. Oh, well, why do we keep hearing about it? Well, you've got to understand one thing. Each year we have to go before Congress for our appropriation. Unless we can scare up a little bit, nothing.
This is Stephen Schneider made he's a mechanical engineer. He got his PhD in mechanical engineering. He's now a biology professor at Stanford. But he writes often on global warming and ozone, and he made a very transparent comment, which was that we really must draw up scary scenarios and ignore the scientific facts in order to get public support for these policies. So the issue is scientific facts are not the top priority on this list. Thank you.